Hello everyone, welcome to Career Launcher, and in today's session we are start 2025 analytical reasoning, and today's topic is cubes and binary logic. So basically, what is the logic behind cubes and what is the logic behind binary logic? We are going to talk about those. Okay, so now I'm going to start with the first question. Now this question says that a cube has six numbered marks 1, 2, 3, 4, 5, and 6. Okay. Uh, Two views of the cube are shown below. Find the number opposite to 6, and my job is to figure that out. Okay. Okay. So there are multiple ways to solve it. The simplest way I'm telling you, if I look at 5, 5 is adjacent to 2, 5 is adjacent to 1, 5 is also adjacent to 4, 5 is also adjacent to 3. And I cannot see 6 anywhere. It means 5 is not adjacent to 6, right? So basically there are going to be, every face is going to be adjacent to 4 faces, and one face is going to be opposite face. So 5 is adjacent to 1, 2, 3, 4. So which number should be opposite to 5? That should be 6. So answer of this question is going to be 5. Find the number that is opposite to 6. That's going to be 5, and that's going to be our answer number 1. Okay. Now let's start another question. What does it says? So it says that there is a cube. There are 6 face painted with 6 different colors, namely black, brown, green, red, white, and blue. Okay. The green and blue faces are neither on the top nor on the bottom. So basically there is a cube. So let me draw the cube. So this is a cube. So I got 6 faces. One is top, one is bottom, one is left, one is right, uh, one is back, another one is front. So we got 6 faces. Okay. Now what does it say? It says there are 6 colors. One is black, brown, green, red, white, and blue. 6. So each face has one different color. That's given to us. Okay. The green and blue faces are neither on the top nor at the bottom. So I know in the top I don't have green, in the bottom I don't have green. The same goes for blue. Okay. The blue face is not opposite to white face. Okay. The green face is opposite to black face. So what I'm going to do, I'm going to give this face a name that is green. I can pick any two. Instead of top and bottom, I can pick any any face. So that is green, and opposite to it, that is going to be black. This is what I know. So I am taking left and right. So left one is green, right one is black. Front and back I'll figure out. So I would say back one is black. Sorry, black one is blue. Okay. So this face, the face that is behind, that is black, because blue cannot be in the top, it cannot be in the bottom. So I'm just assuming it is blue. Okay. Now brown face is adjacent to white face. Okay. Now I have if this is blue, then front face can never be white. This is what that is given to us. Okay. So I have no idea about front face. I have this idea that front face cannot be white because opposite to blue you can't have white. So white has to be either top or bottom. So if I put this as white, then adjacent face means the front face, that's going to be brown. Then bottom face is going to be what? Which one? That is red. Now here I have taken an assumption that white is at the top, but it's not necessary. White can be at bottom. So if white is at bottom, then it's still brown is going to be this front face and red is going to be top face. So top face can be either red or it can be white. Both the values are there. So answer of this question is going to be option D. So if you did not understand this question or you have any doubt in this, kindly do ask. So actually we cannot calculate the value. So there are going to be two possibilities of it. Now the next one. So 27 identical cubes of uh, mm, edges, 1.5 each assembled at a tabletop to make a larger cube of 4.5. Now larger cube is painted with black color. Find the number of smaller cubes who has at least two faces that are painted with black. So now whenever you see these kind of questions, the painting ones, okay, so you need to understand there are, when you are going to paint a cube, all six faces, a cube is uh, going to be having six faces, then it is divided into smaller cubes. uh, let's say you are forming a cube of n by n by n. So in this, I'm directly telling you formula that how we should calculate. So that is exactly three faces painted. How can we calculate? Exactly three faces painted is always going to be 8. That's a fixed number. The corner ones. Exactly two faces painted is given by, exactly two faces painted is given by 12 times n minus 2. Exactly one face painted, that is going to be 6 times n minus 2 whole square. And no face painted, or I would say exactly zero face painted, is going to be given by n minus 2 whole cube. So whenever you see these kind of questions, don't think much. Just directly use the formula. You are definitely going to get the answer. Now this one says 27 cubes, identical cubes are there. So 27 means I can write it as 3 into 3 into 3. That is n is to n is to n. Okay. Now I'm mixing all of them. I'm painting all those colors and all. Then I'm dividing it. Okay, so how many faces? That has at least two faces painted. So what is at least two faces? At least two faces means exactly 2 and exactly 3. Exactly two face painted as well as exactly three face painted. So what is the value of exactly three face painted? That I know, that's a fixed number. That's going to be 8. Exactly two faces painted is going to be what? That is simply going to be 12 times n minus 2 or 12 times 3 minus 2. So that comes out to be 12. So that answer of this question is going to be option D. I hope everyone understood that what is the approach we are going to what is the approach we are going to take to solve these kind of questions. Yes or no? Okay. Now the next one. A cube is painted with red on all of its faces, then cut into 64 identical and smaller cubes. How many of these smaller cubes are going to have exactly one face paint? Okay. So what is so basically how many cubes we got? 64. So what can I write 64 as? 64 can be written as 4 into 4 into 4. Okay. Exactly one face painted. So what is one face painted? That is going to be 6 times n minus 2 whole square. So that is going to be 6 times 4 minus 2 whole square. That is going to be 6 into 2 square, or that is equal to 6 into 4. Answer comes out to be 24. That's option C. That was. If you know the formula, these type of questions are going to be very easy, as well as these type of questions are going to be very much time saving. Now, everyone understood? Yes, no? Okay. A solid cube of 3 centimeter side, okay, is painted on all its faces, okay, and cut up into smaller cubes of one side each. So that is 3 into 3 into 3. Exactly three face painted. What should be the answer of this one? So what is the answer of exactly one face painted? What is the answer for exactly three face painted? That's going to be option B, that is 8, because that number is always fixed. Okay, very nice, very nice. Now this one. There is a dice, okay, that has shown of the following symbols, that is on the face opposite to. Which of the following face is going to be the opposite face of alpha? So what should be the answer? Hmm. What's the answer of this question? Opposite to alpha, I can't have this symbol. I can't have this symbol. Okay. I can't have this symbol. I can't have this symbol. Opposite to alpha, I can also not have this symbol. Cannot have this symbol. So what is the symbol that is left out? That is delta, or I can say triangle or delta. So my answer of this question is going to be delta. Very nice. Very nice. Now this one. Now these type of questions are called as binary logic questions, where in binary logic we figure out that who's speaking the truth, who is a liar, and those kind of things. So basically, a mobile phone has been stolen. There are three suspects, P, Q, and R. They were questioned, knowing that one of them is guilty. Their responses are as follows. Okay. So basically, when we get these kind of questions, we assume that the only person who's guilty, he's lying, and apart from that, other people are speaking the truth. So what is the approach that we should take? Hmm. So basically, the approach that I'm going to take, I'm going to assume that the first person, I'm assuming that P is guilty. So P is guilty, it means P is a liar. So if P is a liar, it means other two people are speaking the truth. Okay. So R did not steal. Okay, that is true. If P stole, it means R did not steal. Fine. I did not steal. That is also true. I did not steal. I don't know who did it. Okay, that's also true. So there is a possibility that P stole, right? Now if I say that Q is lying or Q is so in this case I did not steal it, he's liar. Q did not steal it, he's liar. So basically P might be the guy who's guilty. Now let's start with Q. I am assuming that Q is guilty and Q is lying. Apart from Q, other people are speaking the truth. Okay. I did not steal it. That is true. Q stole it. That is also true. It means P is speaking the truth if Q stole it. Okay. R did not steal it. I did not steal it. So basically, that is a liar. I did not steal it. I do not know who did it. That is also the truth. Okay. So in that case, this guy is speaking the truth, this guy is speaking the truth, and this guy is lying. It means Q can also be the guilty, right? So I am getting two possibilities that P can be guilty as well as Q can be guilty, right? So in this case, I am unable to conclude that who actually did it. Understood? Yes, no? Anyone has any doubt? Now let's move on to the next one. What does it say? There are three cartons. Exactly one of them has money. One on each box there is a statement. Exactly one of which is true. Okay. One is true, two are false. That's what it is saying. So what you are going to do in this particular question? Do let me know what is the answer. Okay, Arup. So I'm going to start with this. Money is in the box. I am assuming that money is in box one. This is the assumption. Then my one statement has to be true, other two has to be false. Money is in this box, that is true. Okay. If I am taking first case. Money is not in this box, that is also true. This is money. So basically, I needed to have two statements that are one statement that is true and two has to be false. But if money is in box one, there are two statements that are true. It means box one cannot be the answer. Now I am taking second case where money is in box two. Okay. Money is in the box, that is false. Money is not in the box, that is also false. Money is not in box one, that is true. So exactly one statement is true, two are false. It means money should be in box two. Now let's check with box three as well, whether it works whether it works or not. So money is not in the box. That is money is in the box. That is true. That is false. Okay. Money is not in this box. That is true. Money is not in the box one. That is also true because it is in box three. It means two statements are true. So that cannot be the answer. It means money cannot be in box three as well. So where is the money? In box two. So did we get the answer? Yes. Okay. So now anyone has any doubt for me? Okay, so with this, let's conclude this session. Take care. Bye bye.